Hello, our topic is microbiology spoilage of processed meat, chilled and frozen products. As we all know, sausage is used to be one of everyone's favorites. The food product used in this experiment is iron mass chicken frankfurters. This food product is mainly made out of chicken meat and soy protein, hence it is high in protein content and it can help to build up muscle. Next, I'm going to introduce the characteristic and specification of our food product. By consuming one serving of frankfurters, 4.7 gram of carbohydrates, 3.9 gram of protein, 4.3 gram of fats, and 73 calories are gained. The specification is frankfurters contains additives. However, the additives added are claimed to be plant-based or synthetic origin. It does not contain trans fat and MSG as well, hence it is good.
Now we are going to talk about food spoilage. Food spoilage is defined as degradation of food such that food become unfit for human consumption, and this leads to deterioration of food quality, origin, nutritional value, texture and flavor are damaged. This is mostly infected with either spoilage bacteria or pathogen. Food poisoning is defined as ingestion of food contaminated by food poisoning bacteria or their toxin. It can be categorized into food intoxication and food infection. Both of these may lead to acute disturbance of gastrointestinal tract.
There are three types of food spoilage, including physical spoilage, chemical spoilage, and microbial spoilage. In this experiment, we are mainly focusing on microbial spoilage. Microbial spoilage can be divided into three types: bacteria, yeast, and mold. Among these three, mold and bacteria are the main concern. So, what is the difference between molds and bacteria? Mold spoilage is visible by our naked eyes. Mold prefers slightly acidic condition, and some mold may cause sick or allergic reactions. The most common isolated genera of mold is Penicillium. Penicillium could grow in a wide range of temperature, produce spores, and give occurrence of green patches. Have you ever wondered how about other species of molds? Sporoticium carnis can cause formation of white spot on food surface, while Cladosporium herbaceum can cause formation of black spots on food surface.
Mold may cause stickiness as food surface becomes sticky. Mold that consists of lipases, which will cause hydrolysis of fat, will lead to decomposition of food. Formation of blister may occur as mycelial growth takes place without sporulation. Green patches will occur due to species Penicillium. Now, we are going to talk about bacteria. Bacteria are small in size as we cannot visible them with our naked eyes. They are prokaryotic microbes as they doesn't have any membrane-bounded nucleus and mitochondria. Bacteria are mostly classified into gram-positive bacteria and gram-negative bacteria. Now, we are going to talk about microbes that cause spoilage to our food product, iron mass chicken frankfurters. Bacteria that we are going to introduce you are lactic acid bacteria and Pseudomonas species. Lactic acid bacteria cause sour spoilage to the food. It ferments lactose and produces lactic acid, which lowers down the pH of the food. The taste of the food is adversely affected, but still not harmful at this stage. Moreover, lactic acid bacteria also cause off odor as it produces large amount of carbon dioxide through fermentation process. Lactic acid bacteria may cause change in color of sausage meat pigment. Other microbial production, such as hydrogen sulfide and hydrogen peroxide, may associate with lactic acid bacteria, primarily lactobacillus. The oxidant may react with the curd meat color compound to form a green chlorophene compound. Pseudomonas bacteria can cause change in fat content. Oxidation of unsaturated fat may take place chemically in air with the presence of light and cause oxidative residivity. Lastly, off odor.
Now let's move on to detection and indicators of microorganisms. Biochemical test is one of the methods used to detect these organisms. There are several methods used for biochemical tests for mold: potato dextrose agar, sabarol dextrose ammonia agar, tryptic soy agar, and several more. However, we are only going to focus on potato dextrose agar. Potato dextrose agar. It is a general-purpose medium for both yeast and mold. It is composed of dextrose, which acts as a carbohydrate source for growth stimulant, and dehydrated potato infusion that encourages luxuriant fungal growth. To obtain mold colonies, tartaric acid is added to the agar to inhibit bacteria's growth by lowering the pH of the agar. In order to obtain results, the agar needs to be aerobically incubated at 22 degrees Celsius for 5 days. The biochemical test results shows that green color colonies are formed by Penicillium species, whereas for Cladosporium species, they form olive green color colonies. Moving on, we are going to talk about the biochemical test for bacteria. We will be focusing on catalase test and oxidase test. The assumption made for different species of bacteria present are Pseudomonas species and lactic acid bacteria. Catalase test. Catalase test detects the presence of enzyme catalase produced by microorganisms that lives in oxygenated environment to neutralize toxic forms of oxygen metabolites, such as hydrogen peroxide. If the test is positive, bubbles will be produced due to the breakdown of hydrogen peroxide to form water and oxygen gas. If the test is negative, bubbles will not be formed. It has been found out that Pseudomonas species have a positive result towards this test, whereas lactic acid bacteria have a negative result as they don't have the presence of catalase enzyme, however they have the presence of peroxidase enzyme. Next is oxidase test. Oxidase test detects the presence of cytochrome oxidase enzyme that catalyzes the oxidation of cytochrome C. In this oxidase test, numbers of reagents can be used for this test, such as Kovacs oxidase reagent, Gordon and Magluts reagent, Gaby and Hadley reagent. Using swab method to determine the presence of oxidase enzyme, dip the swab into the reagent and then touch on the surface of the suspected colony. Then observe the color change. If there is presence of the enzyme, deep purple blue or blue color will be formed indicating production of oxidase. If there is absence of the enzyme, there will be no formation of color. It has been found out that Pseudomonas species have a positive result towards this test, whereas lactic acid bacteria have a negative result towards this test. Now we are going to discuss about the most common sources of contamination and factors that affect the growth of microorganisms. Common source of contamination is usually caused by equipment use, the employees, air and water, and insect and rodents. Starting off with the employees, they are the largest source of contamination due to the warm temperature of their body, which cause most microorganisms can proliferate even faster without the presence of hygienic particles. Next, the employees usually disobey the sanitary practices, which contaminates the food they come in contact with. Moving on to the equipment use. It can be a source of contamination during the processing of food and when it stands alone. It is also due to the air in the factory surrounding contain debris which falls onto the equipment. Lastly, also the equipment itself capable to collect microorganisms. Air and water. Water is always served as a medium used for cleaning the raw materials during food production. Contamination of processing, packaging, storage, and preparation can be caused by air from the surrounding in the factory. Lastly, poor sanitary practices applied by the food plant can also cause contamination. Insects and rodents. The most common insects that can be found everywhere, including food processing factories, are cockroaches and flies. They transfer filth from the contaminated area onto food through their mouth, feet, and other body parts. Moving on to rodents. Rats and mice transmit filth and disease through their feet, fur, and intestinal tract. Source of filth and disease transmitted is usually from garbage dump and sewers. Place of transmission are food processing area, and food service area. Moving on to factors that affect the growth of microorganisms, it is divided into two types, intrinsic and extrinsic. Intrinsic factors, they are parameters that are inherent part of tissue, whereas for extrinsic factors, they are properties of storage environment that affect both food and microbes. The common intrinsic factors are water availability, redox potential, pH, nutrient availability, and antimicrobial chemical. Water availability. It is measured as water activity and known as the availability of water in food to support microbes' growth. Water activity for microorganisms to grow range from 0.82 to 0.91. Redox potential. It has big influence on microbes. They are influenced by chemical composition, specific processing treatment, and storage condition. In processed meat and seafood, oxygen is usually expelled out from packaging and thus reducing EH value. Aerobes needs positive EH value and anaerobes needs negative EH value. Moving on to pH. Low pH can inhibit growth of many species including bacteria. Usually, processed sausage has the range of pH from 4.8 to 5.2. Over the time, pH of the sausage may drop and inhibit growth of bacteria. Nutrient availability. Most common nutrients found in processed meat and seafoods are vitamins, minerals, carbohydrates, protein, water, and fats. Nutrients are very much needed for microbes to grow. Antimicrobial chemical. They inhibit or destroy the spoilage bacteria and pathogens from growing and contaminating the food. Next, we are going to discuss about the extrinsic factors. The extrinsic factors include presence of other microorganisms, storage temperature, and relative humidity. Presence of other microorganisms. Some microbes produces compounds that exhibit inhibitory and lethal effects to other microbes. Examples are antibiotic and bacteriocin produced. Other interference include competition for nutrients and competition for attachment site. Storage temperature. Freezing temperature turns water into ice crystals, which is unavailable for the growth of microbes. And also, low temperature slows down the enzyme activity of microbes. It is known that the danger zone for food is from 5 degrees Celsius to 63 degrees Celsius. Hence, this temperature supports the growth of microbes. Hence, this can be concluded that microbes grow rapidly at room temperature. Lastly, relative humidity. It has been found out that processed meat and seafood have a moderate water activity value. High relative humidity environment supports the growth of microbes due to presence of moisture in the air.
Vacuum packaging and addition of permitted food additives are considered as the preservation techniques. Vacuum packaging is a good prevention of microorganisms. As air is removed, oxygen is minimized, growth of aerobic microorganisms is prohibited. Now, I'm going to talk about the advantages of vacuum packaging. When sausage are frozen in vacuum packaging, texture changes such as odors, slime, discoloration, shrinkage, and moisture loss can be prevented. Hygienic handling of sausage increases the shelf life and better decontamination possibilities. Nitrite is a common preservative added in sausage. It provides excellent protection from botulism and characteristics of colors as well as flavors of cured meat. Nitrites develop aroma and flavors associated with cured meats, and they limit the undesirable flavor as well as slowing down the rancidity. Sulfites or sulfur dioxide is also another usual preservatives added. Sulfur-based compounds occur naturally in fermented beverages and wines. They inhibit the growth of microorganisms while retaining the desirable characteristics of red meat. Sulfites also work well in terms of antimicrobial and antioxidation. They prevent the oxidation of fats that can lead to rancidity. Lysine is a bacteriocin, which is antibacterial peptide produced by the bacterium that can be used as food preservative. It is heat stable and it can fight against gram-positive bacteria. However, there is limitation for added preservatives. Strict laws are applied in these preservatives as they can bring adverse health effects. The level of nitrites is restricted as nitrites can be converted into chemicals which are cancerous in stomachs or during high temperature cooking. Nitrites can form a compound called nitrosamine, which is classified as probably carcinogenic. Some studies suggest associations with gastric and esophageal cancer. Some people might have sulfites sensitivity, which is not allergic to sulfites, but body reacts with sulfites and causes unpleasant symptoms. They may face difficulty in breathing, such as lung irritation and asthma. However, throat allergic to sulfites is even more severe as swelling can occur at throat. Other symptoms are severe asthma, abdominal pain, nausea, and vomiting. For Nissin is special. Nissin is graded as generally regarded as safe by the United States. Nissin is also graded as natural preservatives. In conclusion, preservatives can cause side effects in health if consumption limits are exceeded. Next, I'm going to talk about the extra preservation techniques in terms of storage. When food is served, make sure that food is covered with plastic wraps and prevent it from exposed air as mold spores could be in the air. Then, do not leave any perishable food out of refrigerator for more than 2 hours. As sausage is perishable food, therefore it must be kept refrigerated. Refrigeration only keeps sausage for days, but freezing keeps sausage for months. Open cans of perishable food should be emptied or refrigerated promptly. Consume leftovers within 3 to 4 days so that molds do not have a chance to grow.